Okay, this is a kinematics unit test one. We're gonna talk about the basic physics, AP physics about kinematics. Before we start, I wanna talk about formulas. First one, velocity final is initial velocity plus acceleration times time. Okay, those are four formulas you must know in this unit. And number two, delta x. Okay, so that's the displacement. Then your final velocity plus initial velocity, so average velocity times time. Okay, that's your displacement. Number three, final position is initial position plus your initial velocity times t, and 1/2 times acceleration times t squared. Those are all unit is a distance unit, right? So it could be feet or meter. Okay. Number four, velocity final square equals initial velocity square plus 2AD. D is a displacement, so this also we use a lot. Later on, we're gonna use angular kinematic equation too. It's good to know. So it's very similar. So I wrote it down underneath here. Number one is a angular speed. Angular speed omega. That's a initial angular speed plus alpha is angular acceleration times t. So it's very similar to this number one. Also, delta theta, the angle difference, that's also their angular velocity final initial, and this one average times time. Okay, and your final angle is initial angle plus angular velocity times time plus 1/2 angular acceleration times t squared. Very similar to this one too. And angular velocity final square equals angular velocity initial square plus 2 alpha delta t, delta theta. So this is also same as that. Okay, it's good to know. Let's start here. Okay, number one, what is the magnitude of the velocity after 1.5 second of a ball thrown upward from height of 5 meter at 40 meter per second? So the formula you're gonna use is your v final equals initial velocity plus acceleration times time. Okay, and then what they gave you is initial velocity is 40. So you can say v final is 40, and then you throw upward. So acceleration you have here is gravity. Gravity, I'm going to use this one, but negative side, because gravity going downward. Negative 10 times t, 1.5 second. So then 40 minus 15, so that's 25 meter per second. So answer C. Okay. Number two, for an object that travels 20 kilometer north and then 15 kilometer south, and what is the ratio of the distance travel to the displacement? So you need to understand what is the difference distance travel and displacement. Okay, here's object. It goes 20 kilometer north here, 20 kilometer north, and then from here 15 kilometer south. Okay, so we call this one the initial position and final position. That difference we call this one is a displacement. Okay. Now, what is then distance travel? Distance travel is you have to add this one plus this one. All of them is distance travel. Okay. So always a distance travel is bigger than displacement. Okay. So displacement is just simply 20 minus 15, which is a 5. But distance travel, 20 plus 15, which is 35. And they ask you, what is the ratio? Ratio of distance travel, which is 35, to displacement 5. Then when you reduce by 5, 7 to 1. Okay, 7 to 1 is 7. Okay, now let's move on. Number 3. Two vectors A, B both have a magnitude of 5 units. Magnitude of the vector is the sum of these two vectors could be what, right? So let's say they don't say what direction, okay? Vector has a magnitude and direction, but we know the magnitude, but none of them, their direction is given. So let's say initially, let's say they have a same direction, right? So this on the 5 unit, also 5 unit. Then it will be double, okay? Their sum will be like double. So it will be like 10 unit that direction. But what if the other one is exactly opposite direction, okay? Then their sum is a 0 basically, right? So it could be 0 or it could be 10, okay? If it's the opposite direction, it could be 0, but same direction, it could be 10. And any value is possible between there because if you have, let's say like it has a some angle, okay? Then their sum of the vectors is always their diagonal, okay? That length. So it could be any length between 0 and 10. So which one is the right answer? 5 unit, possible. Okay, somewhere 0 to 10, any value is possible. So 5, 10, 0 also possible. So answer E. Okay, any value between there is possible. Number 4, an object is thrown horizontal velocity 20 meter per second from the cliff that is 125 meter above the ground level. The air resistance is negligible. The time it takes the object to fall to the ground from the cliff is most nearly what, right? So there's a cliff and then there's a ground. And then only you have a horizontal velocity, initial velocity, horizontal, that is 20 meter per second. Okay? And this one is 125 meters above the ground. The question is, we need to find out time when it falls on the ground. Okay? So the formula you need to have is, let's say this formula, h of t is initial plus v naught t plus 1/2 a t squared. I'm going to use it, your acceleration is gravity, which is a negative 10. So when you hit the ground, height is 0 meter, and then initially 125, and initial velocity on the vertical, we have only initial velocity horizontal, but not vertical. So this component is 0. And then 1/2 times a negative 10 is a negative 5 t squared. That's my equation. So I can find out time when it hit the ground. So 5 t squared is 125. When you divide by 5 both sides, so 25. So t is 5 seconds later, it will hit the ground. Okay. Number 5, the rate of change of velocity is definition of what? That is acceleration. What is acceleration? Is a delta v over delta t. So rate of change means your final minus initial velocity over delta t within the time. How much is the velocity difference? That's acceleration. So answer D. Okay. Now let's move on. Number 6, 3 balls are projected from edge of the cliff. Ball 1 is fired horizontally. Okay. And ball 2, if fire angle 30 degrees above the horizontal with the same speed as the ball 1, and angle ball third one, it released from rest. Okay, that means initial velocity 0. So which one is true? Okay, so let's just throw it out some situation here. So you have a 3 balls. Fire horizontally first, so it goes first one like this way. Okay. And then second one is 30 degrees like this way. Same magnitude, but 30 degrees. Okay. The other one is just fall. Okay. Without any speed. Now, which one is true? So when you read the answer choices, is that which one hit earlier or later, maybe at the same time. So horizontal velocity wouldn't matter. We're gonna talk about only vertical velocity. So the first ball here initial velocity is just like horizontal velocity, right? So your y portion is also 0. And this third one is just released from rest. That means this also 0. Okay? So they have a vertically same velocity initially, but not the second one. Second one, it has angle 30 degrees. So whatever that portion here, so that is basically, let's say your Vy initially. I'm gonna say just V initial. Oops. V initial. But that one is a sine theta, sine 30 degrees. Okay, that you have a so Vy side here. For the second ball, you have some velocity upward, like that. So obviously, second one it takes longer to hit the ground, but first one and third one, it doesn't have any vertical velocity. Okay, you have only acceleration for the gravity. So first ball and third ball will hit the same time, but second ball, it has a vertical velocity is opposite direction of going down, so it will hit the later. Okay, so answer is C. Number 7, a rock is thrown horizontally off the building, and the speed of the rock as it leaps towards a hand at the edge of the building v naught. It takes amount of time t to travel from the edge of the building to the ground. Okay, and how far from the side of the building measured horizontally does the rock land? Okay, so you throw, and then this on initial velocity v naught, and then it'll fall like this. They gave you already time. It takes the amount of time t to travel from edge of the building to the ground. So you already know the time it hit the ground right here. Okay, and now what is that distance? They ask you. Distance is rate times time, velocity times time. So your distance. So this is a horizontal velocity. That's what you need. Times time. That's it. So answer is C. So when it hit the ground, how far away from the building is a v naught t. Okay, the initial velocity is only horizontal velocity. So you just multiply that. Number 8. Okay, an object is thrown straight upward, and which of the following is the correct signs of the velocity and acceleration vectors at the moment the object at the highest point? At the highest point, what happened? So think about this way. So the ball is thrown upward, okay, and then it stop, and then start to fall down, right? But we are wondering only that moment is stop here at the highest point. What happened? When it stop, right, at the highest point, then velocity must be 0, so not this one. But acceleration, anywhere in the air, acceleration is always a constant. That's a gravity, which is a negative 10. So it should be negative, right? So basically this is a negative 10 meter per second square. Exactly is a negative 9.8. But as we talked about earlier in the direction of this test, they ask you to use a negative 10. Okay, so answer is D. Now, let's move on. Number 9. A spacecraft has one engine at its tail, which can propel forward 400 meters per second, as well as stabilizing engines on either side, each of which can propel the craft at 300 meters per second, perpendicular to the direction of the tail engine's propulsion. If one of the side engines and the rear engines are simultaneously operating, what angle will the craft travel relative to 4? Relative to 4. That's also important in order to find out that angle. So let's draw diagram quickly. So you draw like this first. It's at 400 meter 4. Okay, 400 meter per second 4. Now, at the same time, it's at 300 perpendicular to the direction of tail engine's propulsion. So it doesn't say which direction, but on the sideway. this way, 300 meter per second. Okay, is perpendicular. Now, question is, so which direction the craft will travel then? So when you draw the this rectangle, and then the actual direction, it will go this way, right? Using vector. So basically, you can think this one is also 300. Okay, that one same. Now, they ask you, what angle will the craft travel relative to forward? So relative to forward means this angle. So you can use tangent, right? So toa. So tangent of theta is opposite over adjacent, so 300 over 400. I'm talking about this right triangle. So this angle, toa, opposite over adjacent. Okay. Now, so theta is inverse tangent of 3 over 4. And then you need to use a calculator. So that one approximately 37 degrees. So B is answer. Okay. Number 10. At the highest point of its trajectory, projectile fired at 30 degrees above the horizontal from the start height of 20 meter. Okay. So let's draw quickly diagram. So here, 20 meter height, and it fire like a 30 degrees, right? And then it'll drop on the ground like this. Okay. Now, so which one is true? So that is instantaneously at rest. At the highest point we talk about right here. Okay. Instantaneous at rest, that's not true, because you have a still horizontal velocity, same as this horizontal portion right here. Okay, we don't know the number is not given, but whatever, let's say initial velocity cosine 30 degrees. That's same as right here too. Okay, anywhere your horizontal velocity will be same along the travel. Okay, your vertical velocity will be always changing, and the highest point your body's vertical velocity is 0, but your horizontal velocity is always the same. We ignore the air friction. Now B, it can travel half the distance to its impact point. So what they're saying is, like here, impact point, that distance is half of that. We don't know that one. And it has a 0 acceleration? No. Right? Then definitely not. Horizontal velocity component equal to its initial value. That is true. Horizontal velocity component, they are equal everywhere. So we don't need to talk about then other things. That one is, like I said, always same. Now, this one, you may use a calculator. Okay. Now, in number 11, a rock is thrown straight downward, 10 meter per second, this time downward, from the height of 3.5 meter. And then how long does it take to the rock reach the ground? So you have here, straight downward, okay, 10 meter per second, and this height 3.5 meter. And then how long it'll take? So you can use this formula, h of t, remember h naught plus v naught t plus 1/2 a t squared. So when it reached the ground, it's 0, and initially 3.5, and initial velocity -10. Okay, t is you're looking for time, and then a acceleration, gravity is -10, so -5 t squared. So this one, you use a calculator to find out. If you don't have a solve function in the calculator, you can use a quadratic formula. Okay, then you're gonna get -2.304 or 0.304, those two values, but negative doesn't make sense for time. So 0.304 second it'll take. Now sketch graph of the following situation. first on position time. So you have to watch out. This is a position time. Okay, so everything this is a position time. And it said, and then velocity time. So this is velocity time. Okay, those are 4 situations. You have to draw total 8 graph. Now, then let's graph it one by one. Slowing down. What is the slowing down means? Remember, slowing down, your velocity and acceleration opposite. Okay? They are opposite sign. Now, speeding up means this opposite. V and acceleration, they're same sign. Okay? That's what speeding up means. All right, so let's draw it up. Slowing down at a constant rate. So like I said, it's an opposite sign. So velocity, so this is position, remember. Okay. So it is a positive velocity, then it will going up. And acceleration should be opposite sign. So velocity positive, acceleration negative, right? That means slow down. So going up, but this one is you acceleration is negative, so should be this way. Okay, so velocity is a positive means going up, velocity negative means going down, acceleration positive, that means open up. Okay, the graph side open up, parabola. Acceleration is negative, then open down. Okay, so in this case, these two, so going up and then open down. So only way you can draw is this portion here. Okay, so I draw this way. Now B is a speeding up, so same sign. So this case, velocity positive, acceleration also positive. So then if you think about it, it's on positive and open up. So that means it'll go this way, right? So I'm going to graph this way. Okay, so that's the that situation. Now C, sitting still. Sitting still means there is a no, I mean, so it's not moving at all. So it should be just this way, sitting still. So your position not gonna change it. D, moving at a constant positive velocity. So it keep going up, but with a constant velocity, so your slope is always same, like that. Okay, so you see that slope is a velocity, which is a constant. Okay, some positive constant. Now let's talk about the velocity itself. So slow down. Okay, slow down. So that means your velocity was some positive value, but it keep going down, right? That means a slow down. Now B, speeding up. So let's say initially it was a 0, and then keep going up, speeding up. Okay, your velocity keep increasing. Now sitting still. Okay, so your velocity is 0, not moving, like that. Okay, now this one moving at a constant velocity, so your velocity is constant. Okay, horizontal line like that. Okay, so I want you to practice that one. It will be on your unit test. This kind of things they always teacher always put on the test. Now this one, next one, number 13. Okay, let's talk about the situation here. Two cars are in a race, and the car A driving at a constant average speed 70 mph. Car B average speed a little slower 65 mph. How long does the race take if it ends when car A across the finish line with car A quarter mile in front of B? Okay, so A will end first, of course, because they start at the same time, but it's a faster speed. So what I can see, by the time, let's say here's the finish line. Okay, let's say car A and car B, they start, but they start like that, but this is a faster. So by the time it finishes A, then your car B is behind, and their distance is right here is quarter mile. Okay, so the situation you can have, total distance traveled for the car A is then 70 t. Okay, distance is rate times time, so 70 t, and at that time, that moment, the car B travel is 65 t. Okay, and their difference is 1/4. Okay, makes sense. Now, so when you subtract, that's a 5t is quarter, so t is 1/20. Okay, 1/20 hours. It doesn't say what time unit. It said just how long it'll take. You can leave it like that or into minute. 1/20 times 60, so 30 minutes. Okay, so it will take 30 minutes to finish that race. Okay, 30 minutes. Now, next, number 14. A straight road starts from rest accelerating 3 meter per second square until it reaches a speed 30 meter per second. Then it applies a brake and comes to a stop in a second. And now, what total distance does the truck cover during the total period of motion described here? So I'm gonna separate into, let's say, maybe distance 1, distance 2. So distance 1 is from initially until it reaches the your velocity is 30. Okay. And then that distance will end, your velocity will be 0 here. And then another information they gave you, in a second. Okay, it will take a second in here to complete stop from here to here. So what I can do is, initial velocity is 0 and your final velocity 30. So I can find out D using B final speed square, initial speed square, plus 2AD, if you remember one of the kinematics equation. So in that D1, your final velocity is 30 here. So 30 square, initial velocity 0, plus what is the acceleration is this, right? So 2 times 3 times D1. Okay, so you can find out D1 here. So that's 900 equals 61. So D1 is, when you divide it, that's 150. So I got here 150 meter. I need to find out then D2. So let's use the same formula. So now final is 0. So 0 square equals 30 square plus 2 acceleration, we don't know, and D2. Okay, what is the acceleration? Acceleration, so it's a constant acceleration, so you can do this way. You're a second later, right? So you're 0 minus 30, okay? That is a delta V over delta T. That's acceleration. So over a second, okay? So then you get negative 15 over 4 meter per second square. So you can plug it in here. So 0 equals 900 plus twice of negative 15 over 4 and D2. So let's see. When you use a calculator, so you can say 30 over 4 D2 equals 900. So D2 is 900 times 4 divided by 30. So I got 120. So this is 120 meter. So what is the final answer? What is the total distance the track cover during total period of motion? Then you have to say 150 plus 120, which is a 270 meter. That's your final answer. Okay, let's move on. Number 15, the engine of model rocket accelerates the rocket upward vertically. The rocket starts from rest and it accelerates upward 5 meter per second square until it engines stop after 4.1 seconds. What is the maximum height the rocket reaches? Okay, so let's say the rocket launches from the ground and it reaches like some certain point here. Okay, and then it'll stop engines and but it still keep going up, right? And then the maximum height it'll reach. So what you can do, so let's say distance 1 and distance 2 because two situation. So D1 is we can use this formula. So your final velocity, initial velocity plus 280, we can use this one. So that time your velocity reaches, let's see, from rest it accelerates. Okay, they give you 4.1 seconds, so you can use this formula that time, your final velocity right here. So your velocity is initial velocity was 0 plus 80. I try to use then this formula, so I have to write down first of all formula I'm going to use, initial plus 80, that's what I'm going to use. Initial 0 and then acceleration 5 and then 4.1 second. So that gives you, that's a 20.5 meter per second. So we know that is a 20.5 when it after 4.1 second later, that velocity. So you can find out that D1. So you can say 20.5 square equals initial 0 plus 2 times A is a 5 and T1. Okay, so you can find out the value. So 20.5 square minus, not minus, that divided by 10. So I got 40.025, 42.025. Okay, so that's what we found the D1. Now D2, so engine stop. Okay, then you can find out this formula again. So V final will be 0 then, right? When it reaches the maximum height, there's no vertical velocity any longer. So you can use, let me write down this formula again, D2. So your final velocity is 0. Initial velocity we found out, that is initial now. So 20.5 square plus 2 times. What is your acceleration? In this case, only gravity, so negative 10. Okay. D2. So you can find out your D2. So let's see. 20.5 square and divided by 20. 21. So I got D2 is a 21.0125 meter. So what is the total distance? You add up. So D1 plus D2 equals that one plus, you get 42 that one. So I got 63.04. Okay, that's the total distance traveled until it reaches the maximum height. Let's move on. Number 16. A car takes a trip where there are two different displacements involved. The car first travels 2 hours, velocity 60 km per hour at 70 degrees north of east. It then turns the travel 3.1 hour at the velocity 93 km per hour at 20 degrees north of west. Now, what is the car resultant displacement from the beginning? So let's throw out the situation here then. It's a little complicated, but let's see. So let's say starting from here. First of all, I need to find out then what distance. 2 times the 60, rate times time. 120 kilometer. But you have to understand what is the north of east. This direction is north of east. Okay, north of east. And then if you draw this way, that's north of west. Okay, you need to understand how you're gonna do it out. So 70 degrees. Okay, 70 degrees. So like here, that's 70 degrees here. That's a north of east. And then 60 times 2 is 120 kilometer. And then it turns travel 3.1. So 93 times 3.1 times 3.1. I got 288.3. That's north of west. So let's draw like this from the horizontal. 20 degrees. The value is a lot bigger. Like that here. So that's 20 degrees north of east. And that length here is a 288.3 kilometer. By multiply 3.1 times 93. So now your final location right here. So they ask you, what is the displacement? So not total distance travel. So what is the total displacement? That straight line through here. Okay. So let's see what you can do. So we know that since this one's 70 degrees here, this one's 70. Why? Two horizontal line cut by transversal, then alternate in angles are congruent. So we know that this also 70 degrees. So okay, the end up with 90 degrees then. 20 plus 70 is 90. So that will be easier then. You can just simply use a Pythagorean theorem. So x squared equals 120 squared plus 288.3 square. So x is square root of that value, right? So let's plug it in. 120 square plus 288.3 square. So I got 312.3 kilometer. Okay, that's how I'm gonna find out. You can do this way, or I know some teachers ask you to use a vector, so you can do this one, this vector, and this vector, and they use Pythagorean theorem. So you can, some people, I know that they're gonna do this way. Let me write down here. So let's say x total. Okay, then you can say this one, but horizontal portion right here. So what they're gonna do is this horizontal portion, and for that horizontal portion. So when you add up, you end up with this horizontal portion only, right? So then you can say 120 cosine 70 degrees minus 288.3 kilometers cosine 20 degrees. Okay, so when you use a calculator, you get negative 229.87 kilometer. So similarly, if you do y total is 120 sine 70 degrees, which means for that portion, sine means right here. Okay, and then also sine 20 of this is only here. So that one plus that one is this, right? So that plus 288.3 sine 20 degrees. Then you will get 211.37 kilometer. So let me rewrite it. So what I'm saying is, right here, that's x total. This is a y total. Okay, so that is a negative 229.87 kilometer, and that one right here is a 211.37. So if you use a if let's say this one is x, I mean let's say r is my x. So then r is square root of negative 229.87 square plus 211.37 square. So if you use a Pythagorean theorem like this, then you're gonna get around like 312.3 kilometer or so. You can do vector notation like that. Okay, you using that x component and y component separate, and then you can have a same answer. Okay, so if you need to take more time to do it, so you can always go back to video and then do it again. but I'm going to erase this one. Now, let's do number 17 then. A ball is thrown upward at an angle of 25 degrees above the horizontal, and it passed the maximum height. Then it strikes a wall 30 meters away from its starting position at the height of 10 meters above its straight height. What was the ball's initial velocity then? So let me draw the situation here. So you have a velocity initially, and then that has angle 25 degrees. 25 degrees angle. Okay? And then the ball keep going up, and then it'll hit the wall. Let's say there's a wall, and the wall is it's at 30 meters away. Okay, and then 10 meter wall, it'll hit the wall down like that. Right, that's the situation. So what was the ball's initial velocity? So you can set up basically two equations here using kinematic equation. So let's separate it. This one, you can say this one v initial sine 125, and that portion is a v initial cosine 25. Oh, not 125. Should it be sine 25? Okay, like that. You can separate it. So now you can say, let's say, okay, 30 meter horizontal, 30 meter. You will take your velocity v naught cosine 25 times a t. Rate times time is that distance. We don't know initial velocity and also time. So, but let's leave it like that. What about horizontally? So I'm going to use h of t equals h naught plus v naught t plus 1/2 a t squared. So to be 10 meter, and initial height is from the ground, right? So then it'll be 0. So this one will be 0. Now initial velocity, only we talk about vertical proportion, vertical velocity here. So v naught sine 25 t, and then this one is we're gonna use a negative 10 for the gravity. So 1/2 negative 10 is a negative 5 t squared. Okay. Now you have two equations and the two unknowns, so you can solve it. So let's say here t 30 over v naught cosine 25. Okay. Now if you plug it in here, let's say 10 equals v naught sine 25, 30 over v naught cosine 25, okay, minus a 5, 30 over v naught cosine 25 square. Okay, if you substitute, only variable now is a v naught. So now this v naught cancel out. So 10 equals, let's say sine 25. Make sure your mode is a degree mode. Okay, minus degree. So sine of 25, that times 30, and divide by cosine 25. I got 13. Hold on 1 second. Sine 25 and okay. So what I got is here 30 times the sine 25 over cosine 25 is a 13.9892. I'm not gonna round up yet. Here minus let's see, 900 times a 5, and denominator is so I know v naught square, and then cosine 25 square. So divide by parenthesis cosine 25, that value square. So I got 5478.49. Okay, so now if you move it around, So 5478.49 over V naught square equals 3.9892. And then when you cross multiply, so let's see, then you get V naught square equals 5478.49 over 3.9892, and I'm going to put square root. So square root and fraction of that point divided by 3.9892. So I got around 37. So this one from here, V naught is around 37 meter per second. Okay, that's your final answer. They ask you initial velocity. Okay, so you can do that. Number 18. Okay, that is last one for this video. Now, a stone is kicked horizontally from the edge of the cliff, and the initial velocity 30, and it lands a flat horizontal beach 70 meters from the cliff wall. And how far above the beach is the cliff? So they ask you, what is that height of the cliff? Okay, what he said is it horizontally kicked 30 meter per second, and then it lands a flat horizontal beach 70 meters. So when it hit the ground, it's 70 meters. Okay, that's the situation you have so far. So let's see what kind of equation you can have now. So I want to find out what time, how long it'll take, the time. So 70, right? So initial velocity is horizontal way only, so 30 times t, right? So t is 7 over 30 seconds it will take when it hit the ground. Now, so question is, how far? So what is that height? Okay, so height is you can say, I'm going to use this formula, right? So when it hit the ground 0, and then h naught, that's what we look for. And initial velocity for vertical direction is 0. This 30 is only horizontal. And then this is negative 10, so minus 5 t squares, but t is 7 over 3. Okay, so now you can find out your height. So when you find out this height, then I got around 27.2. So my first answer, 27.2 meter height. Now, second question, with what speed and angle of impact does the stone land? So actually when it land, so it'll go velocity like that direction, right? So I need to know what is your horizontal velocity and also vertical velocity composition, right? That component. And then I'm going to use a Pythagorean theorem, right? To find the actual velocity when it hit the ground. Now, so your horizontal velocity is still 30. Like we talk about it, it's always a 30 everywhere. Okay? So that one is still 30 horizontally. Only vertically, so okay, what is your vertical proportion? So you can say Vy equals V naught plus AT. V naught is 0. Initially there's no vertical portion. Now you can say your acceleration is a negative 10. And then your t is 7 over 3. That's what we found. And if you use a calculator, then negative 23.3 meter per second. So that portion, right, that Vy here is a negative 23.3. So your final, when it impact the ground, what is the speed? Your speed is square root of then x portion. This is an x portion. So 30 square plus negative 23.3 square. Okay. So if you use a calculator for that, then you get 38 meter per second. That's the speed. Speed doesn't have the plus minus. It's just always positive. It's a magnitude of the velocity. So velocity is a 38 meter per second. Now, what is the angle it hit? So angle you can talk about right here. That's theta. So theta is inverse tangent then operate over adjacent. So you can say 23.3 over 30. Okay, then let's use a calculator for that. So arctangent, inverse tangent of 23.3 3 over 30, 30, right? So I got around like 37.8 degrees. Okay, that's the angle of that data when it hit the ground. Okay, that's it for this video.